Cool, okay. Welcome to this talk. This talk is about micro apps and single page applications. And I am Manfred, I'm a trainer and consultant with focus on Angular-based single page applications. I'm also part of the Google developer expert team, and I'm doing a lot of consultancy and in-house trainings in that area, mainly in Germany and in Austria, and sometimes also in other parts of Europe. My current product is also a workshop. It's a workshop about Angular in the enterprise environment. It shows you how you can architect a big Angular application for your business needs. And I want to start this presentation with a simple question. Did you ever have the pleasure of starting a new software project from the scratch on the green field? Who had this pleasure before? Oh, cool, most of you. Yeah, that's nice. So perhaps you know at the first day your project looks like this. There is this green field with all the possibilities. Everything can happen here. And after some weeks, it looks like this. It is really beautiful and cute, and it does exactly what it is meant to do. But after some years, it looks like this here. And no, this is not a college photo of mine. This is the Frankenstein monster, you know it, this monster that has been assembled of different body parts from different people. And this is exactly what an application looks like after some years, because you have to add additional use cases, you have to add additional frameworks and libraries, and so on and so forth. At the end, you have something like this. And of course, there is currently a well-discussed solution for this challenge, a well-discussed solution to prevent this Frankenstein monster. And it's about splitting a big system up into tinier parts, and we are all calling those parts microservices. I mean, the whole conference is about this topic, so this shouldn't be anything new for you. But now, of course, the question arises, how do single-page applications fit into this game? Because a single-page application is inherently a monolith. It is just a single page. And so we have to find some smart solutions for this. And this is exactly what this talk is about. In this talk, I will present 3 ways to get around with single-page applications in a microservice-based environment. And for this, I will start with a deployment monolith, something that isn't really a microservice solution, but it can be done, and most of the frameworks support it quite nicely. After that, we will talk about hyperlinks, and then we will talk about creating a shell, creating a single-based application shell that can load further single-page applications. And at the end, I will give you some guidance on how to choose the right approach for your needs. But first things first, let's start with the deployment monolith. When it comes to a deployment monolith, you have just one client, but of course, you can subdivide this client into tinier parts. Here I'm calling those parts client fragments. And those client fragments can be developed independently. One team can work on one fragment, and then at the end, everything is put together, everything is integrated into this monolith, compiled together and published together. This brings a lot of advantages. One advantage is it is really easy, because most of the current single-page application frameworks are built with this strategy in mind. Regardless whether we are speaking about Angular or React or Vue, all of them support this way of solve this issue quite nicely. You have one optimized bundle. That means you can do a lot of optimizations with your bundle. And when it comes to bundle size, this is really something that matters for web-based solutions, because the bundle has to be downloaded to your client. And so it needs to be quite small. And you have a consistent UI. It is not the case that the first part of your UI has another look and feel than another part of the UI. But of course, there are also some disadvantages of this. You cannot do a separate deployment, which is one of the main goals of microservice architectures. And mixing technologies is quite difficult. Mixing technologies, yeah, it's sometimes possible, but it is really difficult. And to be honest, I've mentioned it before, this is not a real microservice approach. Of course, when we are going with this approach, because we think that the advantage is overweighting, then we have to think about how to implement this approach. And one thing that comes in mind here are NPM packages. An NPM package is really a simple thing. An NPM package is just a folder with some conventions. Perhaps you have seen something like this before. An NPM package comes with a node modules folder that holds all your libraries you are depending on. There is your stuff, your source code, and there is a package JSON with metadata. Metadata that holds the version number of your package, metadata that holds the name of your package. And publishing such a package is also quite easy. You just have to run npm publish on your command line, and when doing so you can point to a very specific registry, a registry you have set up within your company. To be honest, I'm quite a clumsy person, and most of the time I'm forgetting about mentioning this flag here. And that's why it is nice to know that there is an alternative for this registry flag. You could also create an .npmrc file in your project's root, and then this file can point to your registry. And so everyone who is doing an npm publish command will automatically use these settings within those files here. And the best of it is you can even check it into your source control. That also means your colleagues will check it out, and then they will have the exactly same settings. It's a good old ini file. If you ask me, it's a homage to the 90s. You know, in the 90s we had Modern Talking and DJ Bobo and Windows Free and of course ini files. When you are questioning which registry is a good choice, then I can tell you there are several registry products out there you could go with. One product is Nexus. It is quite common in the area of Java development. Another product that is quite common beyond Java people is Artifactory. Who is using the one or the other one? Oh yeah, you are a lot of Java people here. Nice. When you are using .NET, then you will probably go with Team Foundation Server. And then there is my very personal hero. He is called Vertaccio. It's a very lightweight Italian. And this lightweight Italian gives you everything you need for an NPM registry. You can just install it with one command, npm install globally Vertaccio, and then you can run it with another command. It is really that lightweight. And of course, going with such packages brings a lot of advantages. You can distribute your source code, and so other people can use it, for instance, to integrate it into the shell application, where everything is compiled together. And you have some means of versioning. That means your package has a specific version, and the consumer of the package can decide upon whether to go with the newest version or to go with the older one. Those are the advantages, but to be honest, as everything, there are also some disadvantages, and they can be found on the next slide. They can be found here. So, as it turns out, all those advantages are disadvantages too. Let me elaborate a bit on this. When it comes to distribution, it is just annoying to distribute a package within one project, within one big microservice-based project. Just imagine what happens here. You have to write your library, and then when you are done, you have to publish your library, npm publish. It lands within your npm registry. And then you have to switch roles. You have to use the head of the application developer. You have install your library, npm install. You have to integrate it into your application. And then you will very probably notice, wow, there is a bug. And so you have to switch roles again. You have to switch to the role of the library developer. You are wearing his hat. You have to fix your bug. And then again, you have to define a new version. You have to check your version in. You have to publish everything, and so on and so forth. So as you see here, libraries are not a good fit for project internal usages. Also, when it comes to versioning, it means you can have old versions out there. And this means you can have version conflicts. And somehow, especially within one big project, you want to force everyone into using the same version. This doesn't hold true when you have different projects, but for one project, one and the same version shall be used everywhere. Just imagine what would happen when the first part of your client would use Angular 5 and the second part of your application would use Angular 2. Hell would break loose if those two versions of Angular would be compiled together. One approach to solve all those disadvantages is going with monorepos. A monorepo is really a simple thing. A monorepo is just a big folder that contains subfolders with subprojects. That means each and every client slice, each and every subproject goes into this projects folder. The best thing about this is that you have one node modules folder, and just one. When you remember, this is where all your dependencies are, all the libraries and frameworks you are depending on. And this means that automatically each and every project is using the same version of your dependencies. And of course, in turn, this prevents version conflicts. When we look at the advantages of this approach, we see that everyone has to use the latest versions because the latest version of your current library is just in the folder next to your folder. You just have to navigate using /project/project name to point to your other library. And you don't end up with version conflicts because each and every framework, each and every library you are depending on is placed into this node modules folder. And you don't have the burden with distributing libraries. Just save your modifications and all the other subprojects can access it. Adding a new library is just a matter of adding a folder, and there is a lot of good experience out there. When you look at Google or at Facebook, you will see that there is a lot of good experience. They are using this approach quite heavily. But perhaps also you has used this approach in the past. Who has used Visual Studio, .NET and Visual Studio? Okay, some of you. So in Visual Studio, we have this approach since 20 years. There is the approach of a studio solution, which is nothing else than a folder that contains subfolders for subprojects. Or if you think about Eclipse, who has used Eclipse so far? Yeah, of course. In this case, you have Eclipse workspaces. Just one big folder that contains several projects that belong together somehow. And this is also what you could call a monorepo. The best thing about the monorepo is that it is not a one-way street. You can move back and forth very easily. Let's assume you have this validation library here. And let's assume you want to share this validation library with other projects. You can very easily put this validation library into an NPM registry to share it. That means you can decide also later which goes into the registry and which parts have to stay within your project. Let me show a simple demonstration for this. In this demonstration, I have a simple application for searching for flights. I can click here, I can enter some search criteria, and then I can click to search, and when I'm connected to the Wi-Fi, I should see some flights. I think now I'm not connected, but that doesn't matter at all. Let's have a look into the source code of this application. So what we see here is this projects folder I've mentioned before, and this projects folder holds a flight API folder. And in turn, this flight API folder holds several pieces, and one of those pieces is a flight service. As you see here, it is just a class that allows you to load some JSON over HTTP from this URL here, which is hard-coded. So it is really a simple thing. This is what my library provides. When we look back to the flight application, this is the UI you've seen before, you will see a flight search use case. And here I'm making use of the flight service by means of dependency injection. This is nothing that's new, but something that's really special here is the import statement for this flight service. When you move up to the import statement of this flight service, you have a mapped name. This is not a relative name that points to this or that file, it is a mapped name. And this means that your application doesn't need to assume where the library is located on your hard disk. Of course, this mapping has to be somehow resolved, and for this I'm switching to my dsconfig JSON. Here I'm resolving this by means of TypeScript. And when you look into this TypeScript configuration, you see a path mapping here, and this path mapping tells you that everything that is imported from Flight Workspace, Flight API, comes from this very file here. From this file within Flight API or public API. And this means you are quite flexible here. You could just comment this out and point to another version of your library, and then you could compile everything for a very specific customer that gave you some additional budget. You can even cut out here everything. And in this case, TypeScript will assume that all your libraries have been npm installed from an npm registry. Perhaps you've noticed that I'm using comments in the middle of my JSON file. I know this isn't allowed at all, but do you know what? Sometimes you have to risk something. This really makes me feel alive. No, just kidding. TypeScript is supporting comments here, but in the real world, I would go with several TypeScript configuration files. One for my traditional API, one for a customer-specific API, and so on and so forth. Okay, so using this monorepo approach, we've managed to subdivide a big project into tinier parts. We don't have this one big monolithic client, but we have several tiny clients, several sub-projects. But, of course, the drawback is we have to put all of them into one shell. That means everything has to be compiled together and everything has to be deployed together, which is not in the sense of microservices. And there are also some other disadvantages. For instance, we still have several projects. So one more time, all the advantages are disadvantages too, because these projects are talking to each other. And every time, you know this when you are dealt with microservices, every time one project talks to another project, you have a contract. And of course, contracts are difficult to change. If you don't trust me, try to change your renting contract in the next break, or try to change your marriage contract in the next break. It will not be easy at all. I guarantee you, you will find out. Because when you are changing contracts, you have to argue, you have to discuss, you have to find a new solution, and then you have to find something like an intermediate solution to move over to the new solution step by step. And as you can imagine, this is especially a big drawback when there are several teams involved. There you have the disadvantage that you also just have one architecture, and perhaps we need another architecture in some years. No one knows if our architecture holds true in 5 or 10 years. Perhaps in 5 or 10 years there are better ideas we have to catch up with. The same holds true for your technology stack. Nowadays we have some very popular frameworks like Angular, like React, like Vue.js and so on. But no one can predict the future. And when we think about business software, we know that we have to maintain it for 10 or 15 years or even longer. And so we want to be also flexible here. All of this is hard to change, and we cannot support self-contained teams because at the end, as mentioned before, everything is compiled together. That means we have this one-size-fits-all solution, and we have exactly invented the microservice approach to prevent this one-size-fits-all situation. And this is where the second approach comes in, I want to show you today. The second approach is about using hyperlinks. If you ask me, hyperlinks are quite a major technology. They have been around for 20 years, and I never ever have heard someone to say a bad word about hyperlink. So it seems to be quite a valid solution. When you think about using hyperlinks for integrating single-page applications, you will end up with several single-page applications. You don't have just one, you have several single-page applications, and they are interconnected by means of hyperlinks. And in some situations, this is really the best solution. For instance, when you think about something like an application suite like the Google Suite. The Google Suite contains, for instance, Google Maps. It also contains a big heap of other applications like Google Docs or Books and so on and so forth. Each and every Google application is a self-contained application that focuses one use case. And then, when you want to switch over to another application, you have to follow one of those hyperlinks. And then, of course, another application is loaded into your memory. By the way, the most important aspect of the whole presentation can be seen on this slide. Perhaps you've noticed it. In Germany, in Lower Saxony, there is a village called Steyer. I'm very proud of it. It contains my last name, and I'm also putting a lot of emphasis into this. Okay, so please remember this. This is the most important aspect here. Is someone from Lower Saxony? No? Okay. What a pity. Okay, so when we look at this approach one more time, it is quite a simple approach. But there are also a lot of drawbacks, and one of the drawbacks is you will lose your state. When you move over from one application to another one, you will lose your state. That means when you are moving back, the application doesn't remember anymore what you have typed into it. And this is because a whole new application is loaded into your browser. And to be true, this is exactly what we wanted to prevent when we invented single-page applications. Back then we said, hey, we don't want to load additional pages from the server time and again. Another approach you have to deal with here is the approach around shared widgets. Somehow your micro apps, your individually deployed and developed micro apps have to share some widgets in order to provide a consistent look and feel. Something like this here, this menu component. And for this, web components are a good fit. Who heard about web components before? Okay, cool, about the half. So then you know web components are nothing else than framework-independent components. That means you can write a web component with the first framework or with vanilla JS, and then you can use it together with other frameworks or even with vanilla JS. That means you can write your component once and reuse it anywhere. Somehow this holds up to the promise of Java. When we look at browser support, we've seen a lot of green boxes here. For instance, Firefox, Chrome, Safari, all they support custom elements, which is one of the main standards behind web components. But we also see that the Microsoft browsers are not in the boat yet. When it comes to Edge or IE, they don't support it yet. The good message is, Edge began developing it. It is currently under development in the Edge team, but IE 11 will of course never get it. But I have also another good message for you. You can polyfill web components down to IE 11. You can even polyfill it nowadays for Edge, but as mentioned, you don't need to do this in some months because they started to develop it. And so they will run everywhere. Of course, when it comes to polyfilling features that are not part of your browser, then you have some disadvantages, but trust me, you can live with them. Just begin to test with IE 11 quite early. When you are not testing with IE 11 quite early, you will have a bad wake up in some months. But when you consider all the limitations of this browser, then it really works. You can arrange yourself with it. Okay, this is the story around hyperlinks and around using web components. And as you have seen, in some situations, hyperlinks are the right solution because they are simple and they really easily fit into the world of product suites. But sometimes the user deserves better. Sometimes the user deserves an application shell that is capable of loading different single page applications, loading different micro apps on demand. And this is what such an approach could look like on a high level perspective. You have this shell, it is a single page application on its own, and on demand it loads other single page applications, other micro apps. And for this approach, you have more or less two implementation strategies. I will start here with the most ugly strategy. What do you think? What is the most ugly strategy to load a single page application in the middle of another single page application? Iframes, yeah, you've said it. I don't know about you, but when I hear the word iframe, I get this strange feeling in the stomach. No, just kidding. To be honest, iframes have some really advantages. Advantages you will not find anywhere else. For instance, they provide the best amount of isolation. Isolation means that the application in the first iframe cannot harm the application in the second iframe. An error here doesn't influence the other application. A destroyed layout here doesn't influence the layout there. And they cannot hack each other, which is especially important when you are going with plug-in systems where different vendors are providing different single-page applications you have to integrate. So isolation is a big topic here. Another big topic here is you can very easily integrate legacy applications like Java Server Faces applications or ASP.NET applications or PHP. Another approach here would be to bootstrap several single-page applications. That means you have one index HTML and you load several bundles with different single-page applications in this index HTML. You can load them on demand. That means you can do something like lazy loading. And when it comes to this, I have an idea. I would wrap those micro apps into web components. So you will end up with very big web components. And just to be clear on this is not a typical web component. Normally, a web component is a tiny widget you want to share. But wrapping a micro app, something that's bigger than a drop-down field or another widget, into a web component is quite nice because it provides you a united API for the shell. That means the shell does not know the differences between React and Angular and Vue and all the other things that will show up in the near future. They just need to know about micro apps and about web components, and they need to know how to interact with them. So this is really simplifying your shell. And another advantage of web components is you can easily nest them. That means you can use one web component that is, for instance, written with React within your other web component that has been written with Angular. To load your web component into the browser, you just need a script tag like this. You just need a script tag that points to your bundle, and then immediately the browser is capable of resolving additional elements like your micro app element here. And of course, when you think one step further, you can even do this dynamically. You can create some code that is inserting those tags into your page on demand. And when you are doing so, you have something like lazy loading of micro apps. A question that arises quite often here is how can those micro apps interact with each other? And the answer is web components just behave like ordinary components in your browser. They just behave like a table component or an image component or an input field. And because of this, they can have something like event handlers, and they can have something like properties and attributes. And using this, you can very easily hook up something like a message bus. A message bus that is located within your shell, a message bus that handles all the events that have been published, and a message bus that sends down new data to your web components on demand. Sometimes this is necessary, but in the sense of microservices, I would prevent this. You will need it sometimes, but I would not use it heavily, because every time you need to communicate with another micro app, you are defining a contract. And as mentioned before, contracts are really hard to change. Okay, let me show a demonstration for this. In this demonstration, I have an application that looks similar to the application we've seen before, but now this application is not a big single page application, it is just a shell. The whole purpose of this application is to load other applications on demand into the working area. And here, as you see by the logo, I've loaded an Angular application that I'm also calling my blue client. And of course, this blue client can do everything Angular is capable of. You can switch back and forth using routing, and you can use all the other features of Angular. Here I have also another Angular client, another self-contained single-page application that is just loaded on demand. It's my red client. The best thing about this is all those clients also run in standalone mode. That means you can individually develop them, you can individually deploy them, and then the shell application is just loading the newest version of your deployment into this working area. When we look here, then we see we can even mix and match technologies. I don't remember what this logo is about, but in my point of view, it really shows that mixing and matching technologies is possible here. And one more time, not because we want to have each and every framework to be part of our application, but because we have to. When it comes to software, we have to support in long term. It is smart to have the opportunity to introduce new technology on demand in time. And we can also wrap legacy applications like this Angular.js application and then load it into our single page application here, into our shell. This here is what I'm calling the macro architecture. It's the overall architecture that holds together all your micro apps. Besides this macro architecture, there is also something I'm calling the micro architecture. The micro architecture is what takes happen within one micro app. And within this micro app, you could also reuse widgets from other clients. For instance, here I'm reusing a widget from the green client, I'm reusing a vanilla.js based widget, and I'm reusing a widget from my blue Angular client. You know, when it comes to micro apps, UI integration is a very heavily used approach. But one more time, doing something like this is also creating a contract, so please think twice before you share a component. Okay, this last example provided a big advantage over all the other examples. We now have several small and decoupled projects. And this is really good. But there are also some disadvantages, and we will find them on the next slide. We will find them here. You have several small and decoupled projects. So one more time, what's an advantage on the one side is also a disadvantage on the other side. Why is this a disadvantage? Well, we have more bundles to download. And when it comes to browser-based applications, bundle size and the amount of bundles really matters. It matters for your application performance. The bundles are less optimized, and perhaps you have duplicate code. Perhaps you have some amount of the Angular framework in the first bundle and the same amount of Angular code in the second bundle. Because you have Vue.js in 3 of your bundles, and that means you have to download Vue.js several times. Of course, this brings isolation, because that means that each and every team is self-contained. Each and every team can decide upon its own technology and upon its own version, but it makes your bundles bigger. And you have somehow to deal with UI consistency. No one guarantees you that all those micro apps you are loading on demand have the same look and feel. So you have to take care about it. So let's come to the last point of this presentation. After showing you 3 approaches for writing micro apps with single page applications, you are wondering which is the best solution for my needs. And this question is really difficult to answer. Because you have seen before, each approach comes with its own advantages and disadvantages. And when we are honest, all of you and also I want to go with all the advantages, but with none of the disadvantages. And this is really an issue, and this is why you will probably end up in cycles when discussing this with other architects. I've seen this several times when I did this discussion with my customers. And to ease those discussions a bit, I've created a decision tree that helps you to identify a first good architecture. Of course, it is not the last word on this, but this decision tree really proved to be in handy. Let's have a look at this decision tree. The first question I would ask you is, do you have shared state? And do the users navigate a lot between the apps? And when you say no, I don't have a lot of shared state, and when you say no, they don't navigate a lot between the apps, then try to go with hyperlinks. because in this case you have very probably several different applications that don't need to be one big application. Just go with hyperlinks here. You have all the other possibilities later. You can easily switch to another architecture a bit later. In this case, you will very likely have something like a product suite, like the Google suite or like Office 365. When you say, boy, I have a lot of shared state, and the users are navigating a lot back and forth, because a lot of use cases overlaps the boundaries of my micro apps, then the next question is, do you need to integrate legacy apps like JSF or ASP.NET, or do you need to have the best isolation you can get on this planet within the browser? For instance, because you want to integrate third-party vendor apps. In this case, consider iframes. Iframes are a valid solution here, and I'm seeing this solution a lot out in the field. In big companies, in big intranet applications, I'm seeing this solution a lot. But please also consider, iframes are not a good choice for public websites. You will not write the next Amazon using iframes, of course. And another sad story is you will not win an architectural award with using iframes. When you say no, legacy is not a topic, we live in the beautiful new world, and when you say no, we don't have to integrate other stuff, then the next question is, do you need a separate deployment and a mix of technologies on the client? And when you say yes, then consider bootstrapping several single-page applications, one index HTML and several single-page applications, and also try to wrap them with web components to provide this unique interface to the shell. And when you say no, a separate deployment and mixing technologies on the client is not a big topic for us, then you can go with a monolith. And in this case, consider libraries and the monorepo approach. I know the word monolith is a curse when it comes to a microservice community. But to be honest, you have seen before, it's all about advantages and disadvantages, and sometimes going with a monolith is quite the best solution. It really depends upon your architectural goals. Some people also call this the majestic monolith, because they are saying we will make sure that this monolith is beautiful and has a really nice architecture. Unicorns are seen more often, I've heard some days ago. I'm not sure about this. So this decision tree is about the overall architecture of your application. But in turn, you need also to find some technologies for the micro-architecture of your micro-apps, for the architecture within each and every micro-app. And for this, you have still several choices. You can go with packages. You can use web components to provide shared widgets. You can go with the monorepo approach to substructure a micro-app into even tinier parts. You can use inner sourcing. A lot of my customers are using inner sourcing to share something like styles. And you can also use separate ways. That means each and every micro app can create its own widgets. They will share it, they will just create their own widgets. Of course, that means on the one side code duplication, on the other side you are not creating a contract. You are more flexible. So to be honest, you can put each and every architectural aspect here into the application, into the architecture of your micro app application. If you said, hey, that was a nice talk, I've written a lot about this topic, and you find all my blog articles on my website. It's called Software Architect AT. It's written the German way with an AT for Austria. And even if you say, hey, this was an awful talk, Check out those blogs anyway. Perhaps I'm writing better than I'm speaking. Okay, so let me come to a conclusion. We have seen 3 possibilities to use micro apps within your microservice architecture. We've talked about the monorepo approach that allows you to create a deployment monolith for the client. We've talked about hyperlinks. Think about Google. Think about sharing widgets. And we talked about the shell architecture that loads all the applications on demand. And one big thing here is you need to evaluate it. You need to evaluate all these candidates against your architectural goals. This is a hard task, a difficult task, but perhaps my decision tree helps a bit with this. And one last thing here, please beware the Frankenstein monster also on the client. Thanks for coming and have a nice day. Au revoir.